Hi everyone, welcome back to the Rasa Masterclass. I think the time has come for us to talk about what comes after you build a simple version of your assistant and how you can take it to the next level by learning from real users. It's a big topic and we will cover different aspects of it over the course of the next few episodes. In this one, you will learn why it is important to improve your assistants by learning from real users, what is Rasa X and how it empowers you to improve your assistants, how to set up Rasa X on a server and connect your assistant to it, how to use Rasa X integrated version control, and last but not least, how Rasa X works and what are the most important features you should keep in mind and use when improving your assistants. We have a lot to cover, so let's get started. When developing conversational AI assistants, one of the main challenges is getting good training data. Oftentimes, it all starts with the developer manually generating some example conversations to kickstart the development process, just like we did with our Medicare Locator assistant. However, relying on only one or a group of developers to generate the training data makes it close to impossible to build models that generalize. And here is why. It's very difficult to come up with a wide variety of NLU training examples. And similar for dialogue, you can rely on real users to take the unanticipated paths, but by definition you can't anticipate those paths yourself. Also, when it comes to generating training data, humans subconsciously tend to stick to specific patterns in the examples they come up with. And on top of all of this, hypothetical conversations don't really reflect the real-world conversations, and they may drastically differ from how real users would talk to your assistant. That's why you should aim to involve real users into the development process as soon as possible, because the conversations they have with your assistant is the best training data you can possibly get and use to improve your assistant. So, when is the best time to start inviting real users to talk to your assistant? As soon as your assistant is capable of handling the most important happy path stories, it's the best time to start getting real-world feedback and use it to steer the direction of the development. Take our Medicare Locator assistant as an example. It's still quite a simple application, but it's good enough to collect some required information and run specific actions to fulfill user requests. Getting some real user feedback would help us immensely to take this assistant to the next level. Improve the models using the real-world data, add new skills, or maybe introduce some changes to the existing ones. The best way to achieve all that is by introducing Rasa X into our development workflows. So what is Rasa X? Rasa X is a toolset which allows you to improve the assistants built with Rasa open source. It enables you to easily share your assistants with real users, collect the conversations they have with your assistant, then review them and decide on which minor, major, or architectural improvements you should work on. Since Rasa X is a toolset for improving existing assistants rather than building them from scratch, the only prerequisite for using Rasa X is an existing assistant built with Rasa open source. Let's start with setting up the Rasa X. For running Rasa X on a server, Rasa supports Docker Compose, but you can also find Helm charts to deploy Rasa X on OpenShift or Kubernetes. We recommend deploying Rasa X on OpenShift or Kubernetes if you're planning to ship your application in production because they allow you to set up the continuous integration. For smaller applications, using Docker Compose is a great way to go. In this video, we will show you how to set up Rasa X using Docker Compose, and we'll cover the setup using Helm charts on Kubernetes in upcoming videos of the Masterclass. You can choose what server you want to deploy Rasa X on, for example, Google Cloud, AWS, or your own server, but make sure that it complies with the minimum suggested requirements as shown in Rasa's documentation. It's recommended to use Linux operating system to set up the Rasa X, but you can also install Rasa X on other operating systems as long as Docker support is available. We will install Rasa X on a Google Cloud Compute Engine. So first, let's set up the virtual machine instance. Let's call our instance Rasa X server. We can change the region closer to where we are based, which in our case is Belgium. Let's choose the machine type and pick the one with 2 CPUs to meet at least the minimum requirements. Next, let's specify the boot disk. There is a variety of different Linux distributions you can use. We will select Ubuntu 16.04 and increase the disk size to 100 gigabytes. Let's allow the HTTP and HTTPS traffic to allow the traffic from outside of our network and hit create. Once the VM is set up, we can log into our instance and start the Rasa X installation. We will connect to our instance using the gcloud command, so if you want to follow, make sure to install Google Cloud SDK on your machine. So let's go to the terminal on our local machine and connect to the instance. Perfect! Now we are ready to set up Rasa X on our server. At this moment, our instance is quite empty, so let's download and install Rasa X using the following command. Here, 0.23.3 refers to the Rasa X version to be installed. You can specify this, but we recommend to install the latest version of the Rasa X, which at the point of making this video is 0.23.3. The installation process usually takes a few minutes, and you will be asked to agree with terms and conditions of using Rasa X. By default, the files will be installed in the etc/rasa directory on your server. This can be customized as well. Those files consist of everything that Rasa X needs to run properly and allow you to build great assistants. So, for example, those files are things like credentials, models directory, database, which will be used to store the conversations between the real users and your assistant, logs, where you can find the logs of the container, Docker Compose file, and some others. So now let's start Rasa X. This will also take a few minutes. Once the container is up and running, you should set the password for the admin user of the Rasa X instance. And that's it. We are ready to open up the Rasa X, connect our assistant to it, and work on the improvements. To do that, let's open our server using the provided IP address. For now, we will have to change our URL to HTTP. Let's type in the password we created for the admin user and log into the Rasa X UI. Rasa X comes with an easy-to-use UI, which allows technical and non-technical people to work on the improvements of the AI assistant. Before diving into the usage of the Rasa X, let's first connect our assistant to the Rasa X server. Rasa X comes with an integrated version control feature, which allows you to easily connect your assistant to Rasa X and version control your assistant on GitHub. For that, we have to make sure that we have our assistant on a remote GitHub repository with all the data and configuration files just like we had on our local machine. Once the assistant is on GitHub, we can enable version control feature on Rasa X. At the moment, it's an experimental feature, but you can already test it out by navigating to your user's icon, selecting experimental features, and enabling integrated version control. Once enabled, you should see the icon of this feature appearing next to your user's icon. Integrated version control is a usual workflow in software engineering, which allows developers to version the data and action code on Git, review the changes before they go into production, and run integrated tests on the proposed changes. It's the workflow which we recommend Rasa developers to follow as well when building their conversational AI assistants. With Rasa's integrated version control, you can automate data synchronization with your Git repository, automatically stay up to date with the latest version of your remote repository on Git server, and annotate new data and push the changes to Git. In addition to that, Rasa's integrated version control makes it easier to connect an existing assistant to the Rasa server and work on the improvements. The main requirement for using Rasa's integrated version control with an existing assistant is the project structure. It should be very similar to what you get when you run Rasa init function. Data files should be placed in a data directory, while files like domain, config should be present and placed in the main directory of your project. Once that's cleared, let's authenticate our server. Here is how it's done. First, let's generate the SSL key for our remote repository using the following command. This command will generate a private and a public key. We have to provide the public key to our assistant's GitHub repo to authenticate it with Rasa X. Let's copy the key stored in a git deploy key.pub file, which corresponds to a public key, and paste it in the deploy keys section of the GitHub repository settings. Let's not forget to give the key write permissions. Once that's done, we have to add our repository to Rasa X. Here is how it's done. We have to create a repository.json file with the following parameters. Repository URL is a SSH URL to our remote repository. It can be found once you click Clone or download your GitHub repository and choose Use SSH option. SSH key is the private key we just generated. It's a long key, and remember that you have to provide a full key, including the lines begin RSA private key and end RSA private key. Target branch is a branch which we will point our Rasa X server to, and this parameter can be master. Let's update all details to fit our case and save the file. Once that's done, we have to verify the integration by running the following command, which is provided in the Rasa documentation. It will send a request to our Rasa X server and create a repository. To run this command, we need to provide our server's host URL, which in our case will be the server IP, and an API token. The easiest way to find the API token is to navigate to Rasa X Models tab and click on Upload Model button. Here you will find the API token, which you can copy and provide in this command. Here is how the command with the updated details look like for our assistant. If the authentication is successful, Rasa X will pull the current version of the files we have in our assistant's repository. We can check it by opening the Rasa X UI. At the bottom left, we can now see that GitHub integration icon is suggesting that our Rasa X instance is connected to the master branch of our assistant's GitHub repository. There is one more thing we have to configure. It's our assistant's custom action server. The code of custom actions have to be placed in the actions directory of the server. For that reason, we will create a directory called actions with the file actions.py, where we will paste the code of our custom action. After saving it, we have to create a docker compose override.yaml file to let the docker compose know that in addition to Rasa X, there should be a custom action server spinned up. The parameters here mean that we are using Rasa SDK image to run the custom action, that the action server will listen to a port 5055, and that it depends on the Rasa production service responsible for running the training model, used for parsing intent messages and predicting actions in conversations with users over the input channel or Rasa X UI. After saving the file, we can spin up the Docker container once again and have our assistant fully functioning on Rasa X server. So let's have a look. Rasa X UI consists of 4 main tabs. Talk to your bot, where you can test your assistant and improve it by talking to it in an interactive learning session. Conversations, where you will find the conversations that real users have with your assistant. Models, where you will find and manage the models. And training, where you can find all the current files of your assistant, including training data, domain, templates, configuration, and you can also annotate new training examples and last but not least, train new models after making certain improvements. Currently, our Rasa X instance contains all the files it pulled from the assistant's GitHub repository. Let's hit the train button and train the model with the current training data and configurations. Once the model is trained, we will find it in a Models tab and can select it as an active production model. We can keep on improving the model just by talking to our assistant. In Talk to Your Bot tab of the Rasa X UI, we can talk to our assistant in 2 modes. A simple chat mode means that we can test the performance of the assistant just by simply having a conversation. It's a nice way to test the assistant and at the same time generate some NLU and stories training examples. An interactive learning mode means that while we talk to our assistant, it will ask us to validate the intent classification and action prediction at each step. This way, we can keep on training our assistant and generate new NLU training examples as well as stories for our dialog manager model. In the Training tab of the Rasa X UI, we can find lots of very important sections of the Rasa X. NLU training section contains the training examples of the NLU model. If we click on Training Data tab, we will find all NLU inputs we initially created as well as all inputs we sent to our assistant during the interactive learning session. We can keep the predictions here or we can change them to whatever we think fits better. If we head to Annotate New Data section, we can create new NLU training examples. Rasa X makes it easier by suggesting the most probable intent label to those inputs already. We can annotate those examples and use them when training new NLU models. And what about the stories? We can find them in Stories section of the Training tab. Next to each story, we will find a visualization of the dialogue flow covered by that story. It's a very nice way to see the visual representation of what dialogue turns the story covers. We can edit every story by simply making the changes here. We can also write new stories, import stories in bulk, or generate more training data points by talking to our assistant in an interactive learning mode. In the Training tab, we can find all the other files necessary for our assistant to run, like model configurations, domain, response templates, and we can make changes to all of them here. Most importantly, we can train new models with the new data points and any other changes we made in the configuration. To do that, all we have to do is hit the Train button. In a few seconds, a new model is trained and we should be ready to test it. We can find the new model in the Model section of the Rasa X UI. Here, we can choose a freshly trained model as an active production model, and we can test it again by heading back to Talk to Your Bot section of the Rasa X UI. Usually, this process of building a simple assistant, then improving it by talking to it in an interactive learning session, training new models and testing it again, should repeat until you feel confident enough to share your bot with real testers. Those real testers can be your colleagues, a specific group of people picked for a user test, or pretty much anyone you would like to test your assistant. The feedback you will get and the conversations you will collect between your assistant and those users will help you to make immediate improvements on your assistant. We will cover the entire process of sharing your assistant with real testers in the next episode of the Rasa Masterclass. So stay tuned for that, and I'll see you then.